Hi, my name is Ingmar Bruder. I'm a research scientist in BASF. So BASF is the largest chemical company in the world, and our business segments are plastics, performance chemicals as for example coatings or functional polymers, functional solution as for example construction chemicals, and certainly agricultural and oil and gas. So in the year 2050 it's expected that about 9 billion people will live on this planet, and most of them want to be mobile. And the question is how to find a way to ensure a certain mobility in a sustainable and a cost-efficient way. And one possibility could be to invent cars which drive by electric engines. So what we are doing in BASF is we are developing organic photovoltaics, organic solar cells. And since this is a very complex topic, a lot of people from different professions have to work together. For example, chemists, quantum chemists, and physicists. So since we are a chemical company and we will sell materials, chemicals in the end of the day which can be used to produce organic solar cells, we need additionally partners from industry or from academia to make systems, to make complete organic photovoltaic systems. Traditional solar cells are made mainly out of silicon, and the reason for that is that it can be processed very well, it conducts very well, and it absorbs the light in the right optical range. Here in these labs, my team and myself, we are developing organic photovoltaic devices. And basically one of these devices you can see here, and this type of solar cell was also used in the Smart for Vision. So the main difference between solar cells based on inorganic materials, for example silicon, and organic solar cells is that here dyes are used to convert light into electricity. And BASF has knowledge or a lot of know-how of about over 140 years in inventing and creating new dyes. And what we did here is to invent a new dye class which can convert light into electricity. And the big advantages of these solar cells are that they can produce very cheap, in a very cheap and easy way. You can produce them in any color basically you want to have, and they are transparent. So basically what you're seeing here is are different organic solar cells. You see they are made out of different colors, different dyes, and they are running a helicopter as a demonstrator. But certainly this is a demonstrator, and for future applications you want to power real devices, and how that might look like you can see here. So basically that's a mobile phone charger powered by organic transparent solar cells. And basically here you see my BlackBerry, and I can put it here on the chargers. And you can see here the clock appears, which means that my BlackBerry is charged at the moment. So if you want to design a perfect solar cell, it should be black, because certainly a black color is absorbing all the visible light. However, with organic solar cells we can produce any color you want to have for aesthetical reasons. So if you're buying nowadays solar cells for your house, you have a guarantee that these solar cells will live for about 20 years. They're pretty efficient, and you pay something between €1 and €2 per watt peak. So what we are doing actually here in our lab is to increase the efficiency of the organic solar cells, to increase the lifetime in order to catch up with existing technologies. And even more important, that we are developing here a production mechanism allowing us to produce our solar cells in the end of the day for much cheaper conditions. So if we are talking about market entrance of organic photovoltaics, we have to distinguish between different markets. So for example, if you're talking about consumer electronics, there will be first products available probably in the next few years. If we are talking about construction, then the properties or the issues of the solar cells are much tougher to handle. For example, we have to provide a lifetime of 20 years. We have to provide efficiencies of 2-digit values, and this will take some more years. So as a scientist, you're not reproducing things what other people have done before, or you're not waiting for orders. As a scientist, you have to be creative, you have to be foolish, and that's how I am, and therefore I like my job.